I would like to say that this is our second international scientific conference, Ecosystems Without Borders. Last year we had number one in such international conference, and at present we are participating in the section Green Energy Industry. It is planned to listen to 8 со слайдами, 9 Никишин, да, 10, наверное. 11 presentations are planned. I would like to congratulate you all on this event. I would like to wish you all good health to overcome the difficulties of the current times. And also success in your research and creative activities and in our conference discussions. And now we will listen to the first speaker, a colleague.
Hello, we are starting our conference with the first record. Nikitas Nikitakas, if you're ready, please go to the microphone and start.
Good morning to everybody. Thank you very much for the invitation. It is my honor to be here, and we start also working on the scientific department, on the scientific subject related with green energy, ports, green ports, and all the others. Today I'm going to speak on what is the digital business ecosystem and how this digital business ecosystem will be applied to the port services. I don't know if I'm speaking quickly or...
It's all right, but it was decided to do it without interpretation.
Okay.
Перевод нужен? They say they will
understand.
try and understand you.
As slowly
Без перевода.
as I can.
Это что, профессор?
Okay, this one was a paper produced by myself, by Andrei Nikisic, by Maxim Haritonov. I don't know if Pavel Kovalis. I don't know if I'm pronouncing well the names, but apologize. Okay, the next one. I have to change my hair.
А следующий слайд слышим, да?
Yes. Oops. Okay, what I'm going to say the idea behind the business ecosystem, which is similar to the biological ecosystem that we had, and I'm going to explain what are the main characteristics of the business ecosystems, and also an application that it is the port services. I will start with some statement that says by Rothschild in 1990 that says a capitalist economy can best be comprehended as a living ecosystem, organization like organisms and built in complex hierarchies. One is made up of cells within tissues, within organs, within organisms, within a population, while the other is comprised of work teams inside departments, inside divisions, inside industries. This is the main idea how we start thinking about the business matters and how we are going to think about business ecosystem and after that in digital business ecosystems. The James Moore, which is very, very famous because he discovered that each 1 year the power of calculation is going to be doubled, and it is very, very famous for the Moore law, says that the new paradigm requires thinking in terms of whole system, that is seeing your business as part of a wider ecosystem and environment. in place of the industry, I suggest the more appropriate term business ecosystem. Moore was the founder of business ecosystem, taking the idea for the biological ecosystems and of course applying this one to the business. Okay, sorry. Oh, okay. What exactly it is the theoretical background that we are going to examine here? There is, of course, there was a new complexity. I mean, all the business, as the business that are growing up, they have introduced complexity. I mean, it's not like the old businesses that they were in the old time, but all the new business, they create a complexity. For this one, we have to create a new structure like the business ecosystems in order to treat better couple of things that are coming with complexity. The first one is the so-called self-organization. I mean, each one different matters, they try to self-organize. I mean, to find the optimum way to survive, like the biological ecosystem. The second one is the emergence. I mean, if they are going to find something new, they try all the ecosystems to be there and try to survive. And of course, the third one is the co-evolution and the adaptation. Co-evolution means like the biological ecosystem that the stronger will be survived and the weaker will be disappear. This is the co-evolution, and of course the adaptation, like if you have seen the biological or the animals ecosystems, according to the environment they are adapted. This is the same for the digital business ecosystem. Okay, what is the definition? What is the definition of the digital ecosystems? Actually, there are three different definitions. One goes to the social science, the second one goes to the computer science, and the third one goes to the national science. We're taking some examples of the natural science, and then we're going to apply to the social or the computer science. For the social science, we have a community of users. We have a community that they have the same interest and there are users. Secondly, we have a shared set of languages. I mean, we have in a state some people, some users that they speak the same language so they can communicate. The third one is, sorry because I lose the presentation.
You have a little problems. 1 second.
That's okay, that's okay. We will survive. We are in a digital business ecosystem here. Okay, here. Freezing. Okay, in the social side, as I said, there is a community of users. There is a shared language. I mean, we are here, we have a shared language, English, unfortunately. We have a set of regulatory norms. We are sitting somewhere, we have some regulatory norms. We have a population of services. One service is to present my presentation, the other service is to speak in the microphone. Those are services. And of course, there is an infrastructure. There is infrastructure. We are in a very nice building, in a very nice room, and in a with all those nice facilities. This is the social science. So we are here for a social event. That is our meeting. So this is for the social science. For the computer science, if we are looking at the digital business ecosystem for the computer science, we have several categories of the user. Single user, administrator, let's say super user, and all those things. We have a set of formal language. We have languages like programming language. We have languages that are interactive with operating language and so on. For the computer science also we have a security and identity infrastructure. We have an infrastructure that checks who is going on and who is not going on. A service-oriented architecture, I mean, We have an architecture that provides some services and it is defined by those services. A service development environment, that it is services that, an environment that it is developed for the services, and we'll see in our example what do we mean. We have a distributed peer-to-peer, P2P means peer-to-peer. I'm speaking with each one as a unity, this is called peer-to-peer. There is nothing between us. Runtime, I mean in real time, actively environment, and that's the main characteristic. Also, it is a distributed, persistent storage layer. I mean, we have a layer that we store some information, and somebody can extract some of those information. In natural science, when we have a population of interacting agents, we have different agents that they interact between them. And distributed evolution environment, it is an environment that everyone is growing, and a dynamic, adaptive learning and scale-free network infrastructure. Okay, what we mean the digital business ecosystem? What do we mean with the digital business ecosystem? There are three words: the word digital, the word business, and the word ecosystem. Let's explain what exactly it is each one. First of all, the word digital. It is a technical infrastructure. We have a technical infrastructure. We have based on peer-to-peer distributed software technology. We have a software technology that it is distributed, I mean, is among all the users, and everyone can find and connect to some services. As we will see, all the services, the port services, they are distributed to everybody, so each one can find some services and connect this one over the internet. And of course, there are some objects that it is present within the infrastructure. We have an infrastructure, a digital infrastructure. Usually we have the internet, and inside the internet we are creating some infrastructure, and this is called digital. Business means an economic community supported by a foundation of interactive organization. You will see what does it mean, this one, in port services and individuals. This is the organism of the business world. And finally, the ecosystem. The ecosystem is a biological metaphor that highlights the interdependence of all actors in the business environment, who co-involve their capabilities and roles. This is the definition by Moore. An ecosystem is something that it is transferred from the biological ecosystem and means a lot of agents with common interest and sharing the same business. This is the digital business ecosystem definition, and again, digital business and ecosystems are the three words that we have to define in this presentation. The next one is how is this structure of this business ecosystem. First of all, we have to define that business ecosystem means that we are looking all the system as a whole. I mean, there is not a single point of failure. I mean, if somebody is failure, all the other system is working. And this is the main idea. I mean, although they are interconnected, all the system is working. Of course, there is no dependence for the digital infrastructure from a single instance. I mean, if something happens, it not influences the rest of the ecosystem. Equal opportunity of access for all, equal opportunity for access for all. Scalability means that it could be small and bigger, and so on. And robustness, that means that if we have something cannot influence, cannot fail all the system, but it is robust, can react and recover out of that. In ability to involve and differentiate and self-organize constantly, and of course, activate and support self-reinforcing production and process network. This is the principles of digital ecosystems. The thing that we have to look is that if the failure of one independent agent happens, is not affects the rest of the systems the rest of the ecosystem. Here you will see some more attributes like the capability to enable global solutions that adapt specific needs locally or domain, global solutions that emerge from local and sectoral input, and of course local autonomy. This is how it works, the digital business ecosystem. And you can see right now something like the cloud. The cloud is a concept of digital ecosystems, but of course with different rules. There is a central, somebody who is centric, regulates everything. In the digital ecosystems, there is not regulation. Okay, this is the principle of digital ecosystems. Oops, again.
It doesn't work.
Okay, it works, but very good. Okay, this is what we are called. Sometimes it works and sometimes it doesn't. This is the multi-layered digital business ecosystem. How we are looking the digital business ecosystem. In the lower level, as you can see here, we have the network infrastructure. We have the hardware. The hardware, that means there are connected everything, and there are connected mainly through the internet or to the local network. In the upper level, we have the open source platform. We have a platform that it is open source and it is service oriented. We will see in our case what exactly it is. In the third level, we have the digital components and services. I mean, what are the port services that we are going to serve, in our case, in this digital business ecosystem. And finally, we have the business ecosystem that creates the added value for the digital business ecosystem. Next. Okay. This is a digital business ecosystem, how it works, and mainly how it works for producing some new. So we have here the profile of the user. I mean, each user is registered to some platform or to some network. We have here some colleagues, some different colleagues that they are creating the personal social network. In the middle, there is the network. When in the network there are the members, there are the moderator, there are also discussion. I mean, if somebody is asking something, and of course there are some news and content. On the other side, there are some ideas because we are talking about innovation, and the digital business ecosystems take some ideas and create some products. So this is the meaning of innovation. We have some local groups, that there are local groups but by many persons, and also we have the idea or the project workflow. We start from the idea and we are going there, and we have this business ecosystem that helps all these ideas. Next. Okay, next let's go to more specific things. Let's see what will happen in the maritime field, and I will start with the IMO's initiative that it is called e-navigation, that it is electronic navigation, and it is a way to share different services. On one side, we have the so-called seaboard user over here, and on the other side we have the port. We have the port and we have the user who is taking information or distributing information. Between them, we have the operational services. I mean, we have some services that the ship is needed from the port. And also over there, we have functional and technical services, and of course we have the physical link. The navigation is something that will be compulsory to everybody if you are working navigation. This is the ship, and this is the structure. The ship, they have some structure of data, some format, and the port, they have a specific structure that it is working on that. This is the main ideas of e-navigation, and among these ideas, we will see how we could build the digital business ecosystem for a port. Possibly, I need to change the. Okay, here. After a couple of. Yes. This is what are the services for the port and what are the services for the information system. This is our ship and this is the port administration. So each ship has to own and to exchange some ideas and to take some information. Let me go very quickly. Port community systems, custom is the custom. Sorry, but in the maritime there are a lot of abbreviations that I have to explain. Specific software to this digital business ecosystem in order to understand how this one works. And let's see how this one will be happen. Okay, this is the e-port services. This is the services that we have in port, and we'll try to put all these things. And as you can see, there are the services that there are in the place of, they are located in the ship, those that are located in the port, and those that are located on the interaction that the port community system, that the main, let's say, digital brain of the port, how it is communicated with the other. So we have the ship, the agent, the port services, we have all this for the steel doors, the inlet carrier, the forwarder, and all those things. So everything, all those are services, and we try to create for those services a digital business ecosystem, not only for one port, but for different ports over the internet. So different ports will be connected with our platform. We'll take some of them services in order to make their configuration and to work on that. Okay, so what is exactly we have created, and this was a project that we did in the University of the Aegean, and we investigate more with my colleagues in Kaliningrad State University, how we can adapt all this system to the port of Kaliningrad mainly, but to some other smaller ports in order, without having on-site their services, to get all those services. So here, we have a lot of networking companies that they have a common resource pool. They have a common research pool, so each one company can go inside the platform and select some services and make his own configuration. Of course, we have the e-business that you know, so this platform is trying to work on e-businesses. To connect everybody and to perform a digital, let's say, work, and of course to create different digital spaces like an ecosystem. Each one of the companies is a species of the ecosystem with some specific services, and this is something that it is work all together. If something happened, let's say some disaster, all the ports that are working towards to use all this system. This is how the platform works as an ecosystem tool. And the next one is to see the concept of this platform, and this is the main idea. Those are the resource pools of different services. Custom clearance, charging the anchoring, charging the berthing, load control. Those are different services. Each port, the main port and the other ports that belongs to the ecosystem, come here and they have a configuration. They are selecting which of those services they are going to use. And as you can see here, there are different configurations for each one part and for each one species of the ecosystem. And after that, we are doing an internet space gallery. One port goes inside and directly it goes to the internet gallery. I suppose that I'm in the port X, So I have custom services I have to select. In my configuration model, I have to select custom services, I have to select a lot of other services. So goes there, so at the time that I'm logged in as a port to the conceptual phase, I'm going to this space. And of course we have the administrator, as we can see from the left side, we have the space administration, we have the space services. Of course we are looking to the user interface to make this is more friendly. And finally the grid administration, all this administration, and the user interface, which is very, very important. This is the concept that we are proposing in order to have for a group of ports different kind of services, not located at the same port, but located over the internet. And this is the meaning of digital business ecosystem. And of course, this is my conclusions. My conclusions is the following. Okay, this is the port of Kaliningrad. My conclusion is the following. First of all, the digital business ecosystem is something that it is emerging also in the maritime field, in the port services field. Secondly, we have to take advantage of the conceptual digital business ecosystems in order to facilitate our digital world. And the third one is that in order to survive for the competition, we have to digitalize all our systems, and of course the digital business ecosystem and this kind of platform is the main tool to do all these things. Okay, this one concludes my presentation. Thank you very much for the invitation. Thank you very much for your attention. And I don't think that I have my... No, we finish. I don't think that I have my email, but of course I will be glad if we have the time to discuss and to see how it could develop, because we are in the initial phase. We are working with the guys of Kaliningrad State University, and of course I will be glad if we have some questions or during the coffee break, and I could answer. Thank you very much again.
Вопросы приглашает задавать профессор. Как Валерий Феодосич?
Вопросы есть? Докладчик.
He is asking whether there are any questions
Yeah,
to the speaker.
Sorry.
Нет вопросов, да?
I have tried to learn Russian, but it was very difficult.
Пытался начинать от русский учить, пока еще не достиг.
The thing is that the concept of digital ecosystem is something new. Somebody has to work on that, and we have worked in Europe in some similar cases, and for the port is something new. Right now, and it is something that I investigated in European and Mediterranean, that I am some ports, they have done a cluster. So let me, you have to...
Итак, само понятие бизнес-экосистемы для порта, оно ново. У профессора есть опыт работы в европейских университетах по этому понятию. Он бы хотел, чтобы вы заинтересовались тоже. Вот, вышел на уровень создания кластера в своем исследовании, детализации и реализации понятия экосистемы порта, бизнес-экосистемы порта, бизнес.
This one that I have present about e-navigation will be compulsory for all the ports. I mean, all the ports they should have single window and e-navigation.
И он ввел понятие электронного управления движением судов и реализовал это понятие, да? И оно станет обязательным, то есть идет работа по его превращению в обязательный механизм управления. It will be certified. Your technique has already been certified.
No,
authorized.
It is a proposal.
Это мое предложение, говорит он, ввести в обязательную практику.
We are working right now in security and privacy, which is very, very important. I mean, not be attacked by hackers.
Сейчас работают над стороной безопасности этой системы, чтобы была недоступна для вторжения хакеров, и каждый, кто завел себе там свою часть, да, информационную, чтобы был защищен. Вот это личное пространство, защита и плюс общая безопасность.
And we are applying the public key crypto systems. It is a crypto system.
Применяем криптосистемы.
But this one is against the facility. Take some time and it's not helping so much.
Ну,
But we try to balance all those.
трудоемкое дело применить криптосистемы в таких сложных электронных системах, это требует времени.
Okay. Anything else? Okay.
Thank you very much for your good presentation.
Okay, thank you. I will be available, in the coffee if you have some specific questions to discuss and to communicate.
Подходите, не стесняйтесь, задавайте вопросы во время перерывов, за кофе, с удовольствием пообщаюсь, говорит профессор. Приглашает.
Okay, thank you very much again.
Спасибо. Иллюстратор.
Мы приглашаем следующего участника. У нас подключился Иванов Дмитрий Владимирович с темой «Теоретические основы плазменного процесса разложения сероводорода».
So it is the presentation by Ivanov, theoretical basics of the plasma process of disintegration of hydrogen sulfur hydride. Это к говорящему. То есть мне тихо, так надо найти. Как его фамилия-то реальная была? Фролов. Так, фамилия Фролов. Thank you for the opportunity to take part in the conference. I am presenting the St. Petersburg Polytechnical University Higher School of Electrical Energy Systems. And as it has already been said, my topic is the theoretical basics of the plasma processes of disintegration of hydrogen sulfide. I'm sorry if I will face some difficulties with the technical side of it. It is the first time I'm presenting via Skype. Can you see my presentation? Thank you very much. So the research was carried out at our Higher School of Electrical Energy Systems, and the authors, we are three: Professor Frolov and Associate Professor Ivanov, it's me, and Sergei Zverev is director of our Higher School. A few words first about what is hydrogen sulfide. It is a transparent gas, sweetish, and the odor is that of bad meat or bad egg. It is a binary chemical. This is his chemical, and in high concentrations it's harmful and poisonous. And why? Why did this issue pop up? Because there are industries where recycling of hydrogen sulfide is an urgent problem. First of all, it is oil processing. The amounts could be very high. For example, in Astrakhan, at that deposit, 25% is the generation of hydrogen sulfide. Its high toxicity leads to the necessity of very good processing. So there are a lot of deposits with a high percentage of hydrogen sulfide. The second such industry is oil processing. Gas processing was the first one. So there are certain stages of its chemical disintegration, and it is at the end it is incinerated. And the third industry, generating hydrogen sulfide, is non-ferrous metals. Here there is also generation of this substance. According to traditional methods, one of the traditional methods of its recycling is the Klaus method. It is an unstable process, and the chemical formula is written here, and the transients are named chemical substances in the middle. So the total process at the end has water and sulfur. But environmentally it is not the most friendly process. There are a lot of emissions of a transient chemical into the atmosphere, so the process gives sulfur as its final product, which is valuable, and hydrogen is lost as a result of this process. From the point of view of hydrogen energy, this is a drawback. So it is lost because it is very strongly bound in the molecule at the end of the process. Dissociation, so we could continue the process by dissociating water into hydrogen plus sulfur. It is another method, and the energy consumed for this dissociation is very low, 0.21 only volts. To disintegrate one molecule, the amount of energy is 2.6 electron volts. So we proposed a process of disintegration of hydrogen sulfide. It was proposed by the Kurchatov Institute and by the All Union Research Institute of High Voltage Currents. There they used high-frequency plasmatrons, plasma jets, and here there is an example of another plasma jet facility. Here you see that at the top there is a feed-in of natural gas containing hydrogen sulfide, then natural gas and hydrogen sulfide are separated. Then it goes to the high frequency part, and here sulfur is becomes a sediment, and then the remaining hydrogen sulfide passes further and is sent again to the input, and hydrogen is accumulated. So what is a high-frequency induction plasma jet, a plasmatron? It is shown on the right in this picture. In its simplest form there is an inductor, and inside the inductor there is a tube, and the principle of its action is the same as the principle of a transformer. So there is a current, around there is a magnetic field, very magnetic field, and if the environment is current carrying, then there will be the heating process. This is the main principle of its operation, and plasma is such an environment which has viscosity equal to that of liquid, and density is lower than that of gases. So this is a device which makes it possible to receive a plasma with temperatures higher than 7,000 to 11,000 degrees Kelvin. This is one of the devices which make it possible to obtain clear, pure plasma where there is no pollution from the material of the electrodes. It is closer to the balanced condition compared to other types of plasmatrons, and such kinds of plasma is used in different processes. Examples of these processes are shown on the slide: processing powders, spectral analysis, surfaces, processing, and plasmochemical technologies. In plasmochemical technologies, one of the examples is hydrogen sulfide disintegration. We are dealing with modeling the process of hydrogen sulfide disintegration. These are the main equations. The first one is the equation of energy balance, the equation of motion, the equation of continuity, and since plasma is in a electromagnetic field, we also use the set of equations by Maxwell. Here, the coefficients are properties of the environment: density, electric carrying capacity, viscosity, and a special task is determining these properties changes depending on the temperature and different other varying variables. This is a vast topic, and we have just included here only a part of it, a part of our calculations. We are using the so-called constant method. There are equations according to the law of acting masses. The Dalton law is used, and also the equation of quasi-neutrality and the equation of material balances. As a result of our calculations, concentration of all the components is determined, and this gives us a possibility to calculate thermodynamical properties, density, heat carrying capacity, and transport properties, such as electric current carrying capacity, heat carrying capacity, which are needed to calculate the heat carrying capacity of the electrodes. And these, as a result of our calculations, we can give several examples of the determined properties. The first picture shows the changes in the concentration of these components depending on the temperature. In the other pictures, the upper right-hand corner, it shows the density of plasma. Of hydrogen sulfide compared to other gases, compared to air and also hydrogen. Then dependencies on the heat conducting properties and heat intensity. So the violet color shows the qualities of hydrogen sulfide, and based on this we could calculate the distribution of fields in the plasmatron. This is an example how temperatures are distributed inside the plasmatron, and the temperature, the maximum temperature is 8,500 degrees Kelvin, and hydrogen sulfide is disintegrated at such temperatures, disintegrates. These are our first results. In the future we are planning to carry out a series of calculations to determine the parameters, the rational parameters of the process. Then we will pass over to the kinetic modeling, taking into account the speed of chemical reactions. Then we will find a part will not disintegrate, and we will also develop recommendations for further experimental research. Thank you for your attention. Thank you. Are there any questions? So the facilitator is asking for questions, but no one would like to ask them.
Let us thank the speaker. There are no questions so far, and the next speaker is Viktor Yelistratov, and he will be talking about the reduction of carbon print in the Arctic zone by using wind energy installations. Good morning, dear colleagues. I'm very glad to greet you, to greet Valery Feodosievich. We are happy to speak in front of such an interesting audience. Let me share the screen. with our presentation. The topic
Да, презентацию вы видите.
is, as it is in the agenda, you can see the presentation. Good.
Значит, я на весь экран ее постараюсь сформировать. Так. Хорошо. Итак, тема нашего доклада.
Once again, the topic
Вдвоем
is the reduction of carbon trace in the Arctic zone, and we did it together with my colleague.
России за счет объектов электроэнергетики. Но доклад будет чуть шире.
I will be talking about a wider problem related to the reduction of carbon layer and the policy of low carbon development, which is on the agenda worldwide, including Russia. It was just yesterday when Putin made his speech saying that we should develop low carbon technologies and strive at reducing green gas effect and adverse climate change. We focused on the Arctic zone because in the Arctic zone all these problems related to climate change, they are the most acute and are more definite compared to other parts of the world. The average annual temperature increases twice as fast as globally on the planet. And the total green gas emissions in the world exceed 55 billion tons of CO2 equivalent, including and 30% account for heat and electricity production. The power sector is a driver for low carbon development due to the sector's negative impact. That's why many states today are accepting commissions, are taking upon commissions on the national level about the reduction of greenhouse gas emissions. A few more words about the climatic changes in the Arctic zone. We would like to draw your attention to the fact that it's getting warmer in the Arctic zone. The ice is melting, and in the last 30 years, in the North Hemisphere, has decreased by 2.5 times. In the graphs, you can see the reduction of the area covered by the ice and the volume of the ice. And the left hand graph at the bottom shows the change of the global temperature. And in the last 30 years, the trend has strengthened about increasing the average annual temperature on the planet. The negative impacts have been visualized by us in this slide, and we can see that due to the increase of the temperature, the melting coverage is decreasing, but you can see the current conditions, and this is the forecast for 2070-2090, when practically the whole coastal area of the Arctic will not be covered with ice. The emissions of the greenhouse gases emissions are presented here. You can see the contributions of individual countries in the overall emissions of greenhouse gas. Apart from Russia and European Union, all other countries have positive dynamics of greenhouse gases emissions. In particular, China increase the emissions 4 times. In India, more than 4 times increase. Saudi Arabia, 3 times increase in the greenhouse gases emissions. Many countries have a positive trend in increasing greenhouse gas emissions. That's why a Paris climate agreement was signed in 2015, which was joined by now 197 countries, including Russia. This agreement was passed in order to decrease the global emissions, greenhouse gas emissions, and by the end of the millennium to increase the global temperature not more than 1.5 degrees Celsius. These are some national commitments to reduce the emissions. In particular, the European Commission proposed a European Green Deal to create the first carbon-neutral continent by 2050. Outside Europe, New Zealand has passed a net zero emissions act by 2050. The Russian Federation ratified the Paris Agreement, but abandoned plans to introduce emission quotas because we have a negative dynamic at the moment of greenhouse gases emissions. Though many organizations are taking a decision to reduce their emissions. A few words about the dynamics in the change of the energy policy worldwide. And at the moment, we are in the so-called fourth transfer, energy transfer, related to the development of low emissions technologies, replacing fossil fuel with renewable energy sources, and this is the so-called fourth energy transition. And we can analyze the dynamics of production of electric power in the world by using various sources of energy. And having done that, we can see that renewable energy sources have a significant positive dynamics in increasing their share. In 2019, over 10% of all the electric power was generated through renewable energy sources. This is an overall picture of the global electric power production, and we can see that low carbon development technologies, nuclear, hydropower, and renewable energy sources provide over 36% of the overall energy production. Having analyzed the development of the so-called non-traditional types of energy, solar and wind energy in particular, though it's wrong to describe them as non-traditional because they are very traditional sources. And for the for the wind power generation, the total installed capacity of wind power plants in the world has increased more than 5 times and reached a capacity of 724 gigawatts in 2020, with an annual increase of 50-60 gigawatts per year. And today it's more than 35 gigawatts that are generated on the sea shelf. China, USA, Germany, India, Spain are the top 5 leaders in terms of wind farm capacity. So solar energy is developing even more rapidly, and in 2020 the capacity was 15 gigawatts. In recent years, the annual increase in solar photovoltaic power capacity is 910 gigawatts. And in 2020, the increase was 130 gigawatts in 1 year. The trends in the power sector development are as follows. In the concept of the low carbon development, decrease in the energy intensity of GDP by 2050, according to the various scenarios, the decrease in GDP in the world as a whole may be 1.8% due to a increase in the cost of energy in the cost of production. Compliance with the Paris climate agreements and reduction of greenhouse gas emissions globally from 49 to 55 compared to 2010. Big reduction in the carbon intensity of GDP by 3% due to increased energy efficiency and the introduction of carbon-free energy technologies, increasing and investments in green energy as well. One of the big contributions in the greenhouse gases emissions is done by oil and gas companies. That's why they are in a special focus. And now we will see what is their contribution of emissions in the Arctic zone. Many companies, they commit obligations to reduce emissions, greenhouse gas emissions. And you can see the contributions of some oil and gas large-scale companies in the so-called 1 and 2 spheres of direct emissions of greenhouse gas emissions when producing gas, and it's also about indirect emissions. And we can see that the total amount of greenhouse gas emissions of oil and gas companies is about 825 million tons of CO2 equivalent. From that, the contribution in the Arctic zone is about 110 million tons. These are mostly Russian oil and gas companies which produce oil and gas in the Arctic zone and contribute to those emissions. And the priority areas in low carbon, and for them the measures are to use low carbon technologies, and they plan to introduce more than 120 gigawatts installations of solar and wind installations. Gazprom Neft develops generation using renewable energy sources for a number of their units. Rosneft also considers the possibility of optimizing the emissions in the process of electric power production, and one of the leading companies reducing greenhouse emissions in their production is Lukoil company, which has an ambitious program to reduce greenhouse gas emissions, and they plan to replace already in 2020 340,000 tons of CO2 equivalent. expert reduction of greenhouse gas emissions in the Arctic due to the implementation of low carbon measures using renewable energy sources for oil and gas companies operating in the Arctic by 2050 can be up to 30% from those 110 million tons. About 30 million tons will be reduced with regard to the amounts of gases emitted. And now I will pass the floor to my colleague Roman, who will tell you about the reduction of emissions from diesel power plants operating in the Arctic zone. As far as the Russian Arctic zone is concerned, power supply is done by diesel-fueled installations, and the amount is more than 1 billion terawatt an hour. A plan to modernize inefficient diesel, coal and mazout generation facilities. One of the possible solutions can be module wind diesel installations with a big share of replacement of the fossil fuel, organic fuel, with a smart operation technology, and the reduction can be up to 1 million tons of CO2 equivalent if wind diesel power installations are built in the whole of the Arctic zone. With 50% of replacement of diesel fuel, the reduction of emissions will be about 50,000 tons of CO2 equivalent. And this slide shows a compilation of information about the Arctic zone, and you can see that harmful emissions and the undisposed diesel barrels are harmful. The temperature is rising, the ice is decreasing, flora and fauna population is diminishing, and if wind generation is integrated, then the emission will decrease by 1 million a year. The emission of the SO2 will decrease by 2,000 tons, and CO and NOx emission will reduce by 60,000 tons. We have conducted an extensive research about the possibilities of replacing diesel generation. The wind velocity where the wind velocity is over 50 meters a second, more than 9,000 modular wind diesel generations can be installed with a capacity of up to 100 kilowatts capacity. The cost of power generation is very high in the Arctic zone, and this can be a way of also saving costs and reducing the greenhouse gases emissions. Thanks for listening. Any questions? There is a question.
I will for the last one, I would like to ask something, possibly it has to translate.
Ага, будет с переводом вопрос. Хочет профессор Никитакос задать.
I'm Professor Nikitakos from Greece, and it was very interesting the application of the renewable energies in the Arctic region.
Очень интересная тема поднята, применение возобновляемых источников в регионах Арктики.
But I would like, because I'm doing something in Mediterranean, but the temperature in Mediterranean is very, moderate, let's say. But okay, go ahead.
Я с другими регионами работаю, в частности, с Средиземноморским, и там другой диапазон температур, более умеренные.
For the wind turbines in the Arctic, they need some specific design and some specific rules, because the temperature is very low and influences the electronics of the wind turbine and all the performance.
Поэтому ситуация сильно отличается, та, с которой я работаю, и та, которую докладывали уважаемые докладчики. В арктической зоне нужны другие совершенно конструкции и проекты технические и другие правила эксплуатации в силу воздействия низких температур. Электроника, да, особая. Внимание электронике уделять, видимо, приходится, потому что она чувствительна особенно к воздействию низких температур.
My question is if there are standards for building a wind turbine in the polar areas.
Вопрос состоит в том, существуют ли стандарты для строительства ветропарков и ветровых станций в полярных регионах.
Спасибо большое. Я прежде всего хотел бы отметить, что внедрение ветроэнергетики в Арктике, оно заключается во внедрении так называемых адаптационных мероприятий в конструкцию.
First of all,
Сам ветроагрегат имеет ту же самую конструкцию, компоновочное решение.
So the basic design will be the same, but some adaptational facilities, adaptational mechanisms will be the difference between a wind farm in other regions and a wind farm for the polar region.
Что касается системы управления, то база, как это, господи, то есть конструктивная система управления и элементная база, она одинакова, что это энергокомплекс в Арктике, что в Средиземноморье.
So the basic structure of the control system is also the same for both regions, the Mediterranean, the basis, the basic components of the control system.
Исследования направлены на разработку системы управления, обеспечивающей высокую долю экономии, в частности, органического топлива при работе энергокомплекса.
Our emphasis, the emphasis of our research, is to provide for a high extent of economy in the use of organic fuel. That is our focus of attention. Economizing.
Поэтому наши решения могут найти применение в энергоснабжении островной инфраструктуры Греции.
So our own findings could find some application also for such stations on the islands, even in Greece.
Okay, thank you.
Относительно стандартов несколько слов скажет Роман.
So my colleague will make a comment on the standards.
По системе стандартизации она существует международная система ЕК, которая включает в себя работу, эксплуатацию ветроустановок в холодном климате. Это способы адаптации лопастей, гондолы и башни для суровых климатических условий.
There is the international standard for the operation of wind installations in the polar regions. There are chapters concerning the operation of the vanes, the nacelle, the pole. Everything is covered by the standard, by the international one.
В России, в ГОСТах российских отсутствует пока решение по холодному климату отдельное. Есть стандарты отдельные в организациях, которые используют лучшие практики. И в том числе мы тоже и активно пишем об этом научные статьи, как использовать, применять международную практику для суровых климатических условий. России, потому что они еще сильнее отличаются от международных. У нас есть пояс холода, и нужно те мероприятия, которые существуют, еще сильнее адаптировать для российских условий.
So in the Russian legislation and legislative framework for the energy industry, there are no detailed documents officially adopted, but we are working with best practices. Some institutions, some organizations are studying the best practices in the area, and our institute is doing the same. We are studying the best practices, and it is of high priority for our country because we have very many northern regions for which our findings could be applied, and we are trying to summarize the international also standards and introduce them in our practical activities.
Okay, can I make a small comment?
Хочу прокомментировать немножко, можно?
Thank you very much for the reply, and thank you very much for your offers to use biofuels. We are looking biofuels to the small islands.
Спасибо за ваш ответ и ваше предложение. Мы используем биотопливо часто на островах. Биотопливо используем.
So possibly I would like to exchange some emails and communicate, but also from my experience for the maritime transportation in polars, they need a lot of specific rules.
Но мой опыт работы, а я работаю в судоходной отрасли, в управлении там всеми процессами, требуется большая законодательная работа, нормативная база требуется для обеспечения функционирования в полярных регионах. И для установки таких агрегатов, и для их производства для этих особых районов все должно быть регламентировано, чтобы работало.
And possibly we are looking, we exchange emails to see, because for the wind turbines at the sea, they need specific rules related humidity, related corrosion of the seawater and everything. Okay, but thank you very much for your very interesting...
Я надеюсь, что мы обменяемся с вами контактными данными и продолжим переписку, потому что и меня интересует этот вопрос, и я знаю, что и вам тоже интересно. Очень много требуется нормировать в области влажности, коррозионности при работе вот с такой ситуацией, с таким оборудованием. Спасибо большое.
Спасибо.
Еще вопрос есть? Если нет, я бы пару слов хотел бы сказать. Следует отметить, что идет четвертый энергетический переход, и в рамках этого перехода отслеживаются углеродные следы. А так как мы подписали Парижское соглашение, при продаже электроэнергии и других материалов, Россия она может заплатить, по мнению экспертов Евросоюза, до 8-9 миллиардов долларов.
So we are now experiencing the fourth energy transition, and Russia, experts think that Russia may have to pay a huge amount of money as a penalty because of the absence of such norms in our legislation, up to 9 billion евро или долларов. Dollars.
Поэтому та работа, которая ведется, она, конечно, позволит России значительно сэкономить такие деньги.
So it will be very important for our country to economize. The amounts are huge.
Так как та работа ведется, которая по руководству научной группы Иллюстратова, она позволит России сэкономить большие деньги при продаже электроэнергии и других продуктов.
So the research, the team led by Professor Illustratov is quite valuable for our country as a whole, because when selling energy abroad, the country will substantially economize on the penalties.
Спасибо, Валерий Федорович. Мы будем продолжать по снижению углеродного налога.
Thank you. We'll continue working on that. We'll try to reduce the carbon tax and carbon penalties. Thank you.
Партнером нашей конференции является the Baltic University Program. И сейчас мы послушаем доклад одного из представителей данной программы из Германии. К сожалению, он не смог к нам сегодня, но он отправил видео, которое сейчас мы запустим и покажем.
Now we'll be watching a video sent by our German colleague Markus Will, director of the Center of
Corporate Common Accounting on the International Conference in Kaliningrad. Thank you very much, and I appreciate the invitation which came by Pavel, which is the DOT Center Director in Kaliningrad. So thank you very much. My name is Markus Will. I'm working at the University of Goda, University of Applied Sciences. We are running the German DOT Center, and I'm very happy to share our latest ideas about the issue of climate neutrality from the corporate perspective. So my talk is a little critical, and it will take 10 minutes, and I started my timer right now. So I'm going to talk about phase zero, because I have the impression that a lot of companies recently are on the way to climate management, to climate neutrality, and try to keep it as soon as possible. But I have the impression also that this is no real reduction of GHG emissions as we can see in absolute terms. So this is what I want to talking about. This is phase zero. So let me start with that presentation with a short overview. Usually I try to present my idea in that way. I describe the problem, I describe the solution, I describe the problems that I have with the solution, and then I draw a conclusion. For that I have still 14 minutes. So basically, I skipped the introduction because everybody knows that decarbonization or climate neutrality and reaching net zero GHG emissions is not only a political goal, but also a scientific necessity to avoid catastrophic climate change. So a lot of countries have committed by signing the Kyoto and the Paris Agreement that we need to go on that way. And if you have the latest leading IPCC report AR6 in mind, that you know that this action is needed, and a lot of companies are taking this sort of challenge and try to do something. But what means something, and taking that from the goal perspective, is something, and the overall goal is net zero emissions, which describes a dynamic state where the anthropogenic removal of GHG emissions balance out the anthropogenic emissions that we have produced over a specific period of time. So we emit something, and now we remove something, and this is net zero emissions. So that's the goal. That's here, and I'd like to present that also in that figure. So we have emissions, and we need to bring those emissions down. But we know that mankind is a little bit slow in taking action. So according to the IPCC report, it's now absolutely necessary also to remove GHG emissions from the atmosphere in an artificial way. So on the one hand, what we can do is a fuel switch to renewable energies, or to, let's say, less carbon intensive energy carriers. Hydrogen is the new hot topic, at least in Western Europe, I would say. We can also focus on savings and reductions and on efficiency. But as we have seen in the last 30, 40 years, progress which is made is absolutely too slow. So what we also need is to take out GHG from the atmosphere. That we can do that with technologies, let's say, with direct carbon removal technologies, negative emission technologies, as they are called, and also nature-based solutions in the end. If you have questions on details, please put them in the chat or ask simply in the discussion round afterwards. So besides the techno phase, there is also, let's say, a bookkeeping phase. This means that we do something like external compensation or offsetting. So people, individuals, even countries and companies and organizations try to compensate their emissions by financing projects elsewhere that help to reduce GHG emissions. And then they are able to trade the credits on international markets, and this is what we would like to talk about a little bit more in detail. So what is the corporate climate management in that way about? So we see here a figure, a relatively new figure that shows that we have the Fortune Global 500 companies, and let's say 10 to 16% of those companies, they have committed already to climate neutrality goals, and they are pushing climate neutrality claims, and this is a little bit more in detail. They would like to become carbon neutral, or they would like to switch to renewable 100%, or they would like to get net zero or even carbon negative, like Microsoft or other big players in the market that's striving towards that goal. But as you know, I'm a little bit pessimistic when it comes to those goals, because I ask myself, how do they want to reach those goals? And here we have different levels of action. First level is technology. That would mean expansion, radical expansion of renewable energy, green hydrogen in brackets, I would say, blue hydrogen, maybe an intermediate option. But then the focus must go towards that carbon capture and storage thing, negative emission technologies and other large-scale technologies that we have at hand, but which are very, very, very expensive and up to date, also not very effective. And when it comes to drawing out GHGs or carbon dioxide from the atmosphere. On the organizational level, what are organizations, companies doing? They are running environmental energy management systems. They try to improve energy conservation, energy efficiency, but be cautious. Also here, we have that rebound effect, and we see, at least in Germany, that the political goal of 2% energy efficiency gain each year is by far not reached on the national level. But this does not mean that the ideas that people have there are not worth to follow. It's definitely worth, but it must get some movement and momentum in order to reach the net zero goal. On the product level, what companies can do is use of renewable energies and bio-based materials or recycling, or circular economy, circularity of products, and the balance sheet, climate neutral position, and this is an interest, let's say. So the idea is avoid, reduce, substitute, or compensate, and I would like to speak about the compensate and reduction things a little bit more in detail now. So this is basically the task of corporate carbon accounting, and there are different standards and approaches. Some of you may know that already. So we have for each level a lot of international conventions on the methodological approaches and also on the management approaches. The summary is given here, and I would like to describe that a little bit more in detail in the paper afterwards. Let me focus on two particular things. The first thing is the carbon footprint of products. That means accounting and calculation of the carbon footprint of the product, and then I would like to speak a little bit more about the compensation issue. So carbon footprint of products, what is that? This is the total sum of GHG emissions and removals in a product system, which we can express as simply carbon dioxide equivalent, and this is based on a life cycle assessment for climate change. This is very easy to understand formula, but that's not the point in my talk today. I just want to give you a short impression about that. So what we are doing, according to ISO 1467 and ISO 1440, is basically a life cycle assessment, which means we have a following scope, we take up the data and life cycle inventory, and we make an impact assessment, we calculate the carbon footprint, and then we interpret them. What are the problems? The problem here is that you actually need a critical review, and we have some, let's say, methodological tricks that often are applied, or let's say pitfalls and challenges. The first thing is that imagine you would like to calculate the carbon footprint of a car, then you can easily understand that we have to cut the system boundaries somehow, and we need cut-off criteria for that, especially when we have global supply chain and global supply chain networks at hand. Then the effort to calculate the footprint is far higher than expected. So what we need are to set the system boundaries accordingly from a pragmatic perspective. The point is then that you, of course, this will have an influence also on the result. And we see that sometimes there are upstream or downstream processes cut it out that we actually would need to get a reliable result in the end. So the question here is, how can the effort for the analysis how can it be limited, but also how to prevent that we do a green or blue washing of the result. So the whole idea of the carbon footprint of a product, we take activity data, we take an emission factor, we have the global warming potential, and we have the greenhouse gas emissions. Quite simple calculation. And this is then actually the result. And what you say here is, what you see here is that we have on the one hand the positive values, which are the GHG emissions from different sources, so fossil fuels or fossil resource use. Then we have the GHG emissions from direct land exchange. And then we have on the negative side the GHG removal from biomass growth and the GHG removal from direct land use change. And we see here a very good example of the carbon footprint calculation of a product which uses at least partly bio-based materials in the plastic sector. So here the question is that already climate neutral, or is it even climate positive? And there are lots of questions to interpret. My second point, and I have 4 minutes left, is the offsetting topic. So offsetting means that we compensate the residual GHG emissions. So we try to cut down emissions by technological measures, but this will not reach the 100% level. So we have emissions left, and those kind of emissions we are going to compensate. And there are on international markets a lot of different schemes already in place. We have a compliance market in the European Union, but also internationally coming since the Kyoto Agreement, the Kyoto Protocol. We have that with joint implementation and key development mechanism, etc., etc. And then we have the voluntary market where individuals and companies can trade the so-called emission allowances or emission saving credits. And there is a lot of money in that market, and what kind of options do we have here? Offsetting and compensation by fuel switch and energy efficiency, removal by negative emission technologies and nature-based solutions. And here we are going to finance projects that invest money into projects connected with fuel switch, energy efficiency, or even removal. And removal would mean that we finance humus built up in soils for the use of biochar, or let's say the production of bioenergy and carbon capturing. And there are a lot of other examples that I need to cut out. A new approach is the topic of insetting. Insetting means that we try to finance projects for GHG removal within the own supply chain. So we go into cooperation with companies that are in our supply chain network, and we finance there from our supplier projects that help to reduce emissions in the scope 3 level. And there is, for instance, the International Platform for Insetting, which is doing a lot in that sector at the moment, and there is some, let's say, momentum also there. What are the pitfalls? And here I'm coming to the end. What are the methodological problems of accounting and footprinting, and what are the challenges in offsetting? So we have always the thing that compensation is also like something like buying out, indulgent trade, let's say. On the other hand, compensating is even better than doing nothing. And to my mind, the great advantage of carbon trading is that we create an internal carbon price which may allow us to take costly energy efficiency measures because it will compete with that internal market. So what we would actually need is a carbon price of 80 to 120 US dollar per ton of carbon dioxide to make like effective reduction measures competitive in internal markets. On the other hand, the price development it's exactly in a contradictory way. So the carbon credits are very cheap at the moment. They are dumping prices, and here we don't have any real investment incentive. So then it's not simply a buyout. For instance, there are big aviation companies that compensated all their flights for the customers for a price of €3 per ton of carbon dioxide, €3 per ton of carbon dioxide. That's dumping price. They got certificates on the national market for that. Here you see an overview on selected companies and their internal prices, and this is the way where we need to go. So World Bank social cost of carbon is $30, but we would need something like above the $100 level in order to create incentive for doing something in the real life and to have real carbon dioxide or GHG cut-off. What are the quality requirements when it comes to challenges, to offsetting? When people are going to buy credits, then they need to finance projects that fall under the additionality claim. That means the finance project would not have taken without this financing. We saw that under the clean development mechanism, for instance, carbon credits were put on the market for projects that would have been built anyway. A lot of hydrogen power plants in Africa, for example, are big. So what we need is an additional effect. Then we need permanence, at least for 50, 60, or even 100 years. And here, the idea of creating artificial carbon sinks, for instance, in buildings is an innovative idea to follow. Monitoring and verification must be done by external verifiers in the consultancy, and here we need some sort of quality assurance. And there's the problem of leakage, meaning that carbon reductions would take place at places where the legal background is quite softer. And we need also an external validation, and the timing of issuance is also important. We have that ex post and ex ante certificate, and ex post would mean that we refinance projects that are already in place, and ex ante financing would mean that we collect money actually to do some projects in the future. But I get, when I invest there, I get the credit already now, and the project is not realized yet. So here we need quality assurance systems that allow us to guarantee that those projects will stay and will be realized sooner or later. And then we need some sort of transparency in all that carbon credit trading, and this is not in place right now. On the other hand, we need to avoid double counting, and somehow a contribution to the sustainable development goals is appreciated with stakeholder engagement, and here we can find projects that help, for instance, in developing countries to meet the SDGs, and these are everything you read the paper that will come afterwards with as I draw my simple conclusion. The simple conclusion is, if we are going the way of carbon accounting, and if we are using claims for carbon neutrality, then you should ensure also credibility. And this means that beware of rash neutrality claims. I consult a lot of companies as an external expert, and all of them, they would like to have their products carbon neutral as soon as possible. But I don't think that die Carbon-Neutralstellung, putting simply the label of the product is enough, and I would take some time for it to do it on a very robust basis. That also means that carbon footprints that are calculated should be calculated by experts, and their results should be externally reviewed. The external communication should be well focused, and the most important thing, carbon offsetting is not everything. Real action is needed, and for the residual GHG emission, high quality certificates are recommended. And this is my end, and I thank you very much. Sorry that I cannot be there in Kaliningrad. I am in the hospital at the moment, sitting here in my hospital room. But it was a hard thing for me to contribute to that conference. So I hope that you will have a successful conference and a fruitful meeting and very much inside. So thank you very much.
Уважаемые участники конференции, мы объявляем небольшой 10-минутный перерыв, когда вы можете немного перекусить, выпить кофе и пообщаться друг с другом.
Коллеги, на будущее я
A break has been announced for 10 minutes now. Now we
analysis of power generation by an autonomous solar power installation in the Kaliningrad region.
Представляю доклад на тему анализ электрогенерации автономной солнечной электростанции в Калининградской области. Несмотря на существенное
Despite the advantages of traditional energy sources compared to solar and wind energy, in certain situations, in order to provide with power remote facilities, telecommunication facilities, for instance, renewable energy sources will serve an important task. Despite the economic attractiveness of using alternative energy sources for electric power supply to remote mobile communication facilities, these projects also have their bottlenecks. These are the interface data for identifying the configuration of the wind and solar installation, and these are the peak capacity, the peak load capacity, the nominal capacity of the solar panels, the nominal capacity of the wind generator. Depending on the weather conditions, we calculate the annual generation profile, and based on that figure, we calculate the total daily amount of energy consumed. The calculation of the insulation on the surface of the Earth, it's a difficult task, and the solution needs to consider a big number of circumstances. There are many empirical and semi-empirical approaches, and with certain allowances used. The conditions to be considered in order to calculate the insulation on the Earth's surface, it is necessary to know the direct component of insulation on the surface and others. In our research, we needed to calculate the instant we needed to develop the model of daily integration. The model of the daily integration showed good results, and that's why in our work the calculations will be done based on that model. The conditions may change during the daytime, and the instant insulation may change. calculation was done for the conditions of the Kaliningrad region. We use the MATLAB software for forming the annual data about insulation in the Kaliningrad region based on NASA data. In order to make the calculation, we also had to insert the coordinates, longitude and latitude of the location of the solar panel. What also mattered was the sunlight angle at a certain hour. Figure 1 shows the calculated profile of insulation on the surface of the solar panels with the inclination angle of 30 degrees. In order Figure 2 showed the assessment of the reliability of data. This is what the model of the solar power station looks like. The scheme includes all the relevant functional blocks. The modeling, the simulation of the installation work was done for the conditions of the Kaliningrad region. The graphs in figure 5 shows the capacity of the power generated by the solar panels in July and in January. The study, this is what the solar panel looks like. It's equipped with 24 helium accumulators with a nominal voltage of 2 volts and capacity of 650 ampere hours. The controlling was done through the conversion of electrical energy from solar panels. Accumulation and of data was also carried out. This is the instant generated power. According to the data of the client, the consumption of the power should be between 8 and 10 kilowatt hours a day, and the simulation showed that at least 20 solar panels of that kind were needed for the project, for the facility to provide power within 72 hours. In order to provide the full coverage in energy demand of the client, additional wind turbines were installed. Accumulation batteries were also involved. The power generation by solar batteries is not even and depends on the amount of the sunlight. The amount of the generation depends on the season, and The graphs show the daily amount of energy generated in November and in June. In June, it's about 32 kilowatts an hour, and the consumption is 10 kilowatts. In the greater part of the year, the amount of energy generated by the solar battery is excessive compared to the needs.
Годовое энергообеспечение составляет 100% в целом во все месяцы, кроме 4 месяцев с ноября по
The energy generation covered the demand 100%, with a few exceptions in the winter months, and for that, additional wind generation has to be added. As conclusions, in conclusions, we can say that we have developed a method of calculating the instant values of installation on the basis of average statistical parameters for a month. We have assessed installation per square meter on a slanting surface for the conditions in the Kaliningrad region. We have drawn graphs of changes in instant values of insulation for the 21st of December, 21st of June, and the 1st of March. We have created and tested a model of a solar power installation using the software MATLAB. The parameters included, the installation included 20 solar panels with the nominal capacity of 300 watts. Thanks for listening. Thank you very much. Are there any questions?
Can I ask something? Thank you very much for your presentation. I would like to ask, because I have done something similar, what kind of batteries you are using, and if you are facing some cracking problems, because I can understand that there is a change of temperature in your PV cells.
Итак, вопрос задается, потому что занимается аналогичными вопросами профессор. Говорит, вопрос состоит в том, какие батареи вы используете, аккумуляторные, и сталкиваетесь ли вы с проблемой растрескивания, поскольку есть разница температур. Так прозвучало, может, я не все понимаю.
We are using 24 gel accumulators, 24 helium.
2 volts, and the capacity is 650 ampere hours. Cracking, no such problem previously. Up to now, have not experienced.
Possibly, if the time is passing, we will face some of them, because in my project I'm facing a lot of corrosion with at sea. Okay.
Со временем, наверное, столкнетесь с разными повреждениями, в частности, у меня коррозионные повреждения, но это требует накопления усталости. Because yes, you are certainly right, Professor. We have been working with the equipment only for 1 year. It's not enough, evidently, to see any damage, any accidents. Why not lithium ion, but helium batteries? There is a plan to build a plant producing lithium ion batteries. Why not these?
Да, я слышал о том, что будет строиться завод, но на данный момент, когда мы собирали установку, у нас, к сожалению, будет только гелевые.
We used what we had when
started.
Выпускает тоже регионы. И вообще сейчас очень одно из направлений энергетического перехода, да, это накопители, да.
So energy storage facilities is one of the very important areas.
Смотри, вообще-то накопители электромобилей все во всем мире базируются на литий-ионных аккумуляторах.
All over the world, lithium-ion storage facilities are widely spread.
Can I add something, a small comment? Of course, everything depends on how much money you have.
Все зависит от финансирования, конечно, прежде всего.
In my project, I'm using as a storage device compressed air.
У меня сжатый воздух, такое хранилище я использую.
And I can send you some more information. Of course, we can exchange. I mean, to use compressed air, which is cheaper, of course, initially costs some money, but the compressed air, it's much cheaper because the batteries always they face problem and need to be replaced. But lithium accumulator, I think, should be okay.
Говорит, литиевые ионные тоже, конечно, хороши, но вот на сжатом воздухе, говорит, это изначально первое капиталовложение, там небольшое, они, так сказать, экономичные. И их в эксплуатации тоже они экономичны.
Есть еще вопросы, коллеги?
Да, у меня есть вопрос, может быть, даже несколько. Меня в первую очередь впечатлили результаты исследований. Мне интересно, если
The second question is about modeling. So in your presentation, I have not seen any results concerning modeling, the modeling part. Depending on the experimental capacity, and what is the convergence of energy production produced experimentally and theoretically. You mentioned the fact that clouds influence very much, so it would be very interesting to see how convergent would be actual data with simulated data. In our general calculation, so on one of the slides, I mean, how influential was it for your final theoretical curve? That was the question. Or you have not yet made these comparisons? No, he says, no, I have not yet.
Наверное, вопросов больше не будет, поэтому благодарим докладчика.
Thank you.
И приглашаем решение
And
проблемы.
now the next speaker will be Глеб Решетников. Good afternoon, dear participants and guests. My topic is the presentation is still opening. Retrofitting of wind installations using asynchronous generators, and example is the wind park in Kaliningrad. First of all, we studied the historical stages. Beginning with 1977, these installations started being produced, and they started being used in large-scale energy industry. And asynchronous generator wind installations are simple in their structure. That is why we used these. There is the block of this wind installation. We will be working in the future in our project. So, wind installations of average capacities. So could not switch to the next slide. In this project, we'll be dealing with the renovation of the wind installation, Wind World, which was being used in the Kaliningrad region from 2002 to 2017. This is the block scheme, the flow chart, and the technical characteristics. You can see them on the chart. So the method of connection to the grid is via a distribution network, 110 volts. This is the voltage of a substation, of the substation in Kaliningrad. While researching, we analyzed the main reasons of shutdowns and the main characteristics of this installation during its operation. 14 years was the time it was being used. The main factor is the low phase voltage on the terminals. The low phase voltages at the terminals of the asynchronous generator. So we put forward two hypotheses. The first concerns the reason that maybe the criteria of connection to this, so the correlation between the capacity of this wind installation is lower or equal to 200. And the second hypothesis said that we are dealing with a compensating facility. That is one of the reasons when checking. Please help me with scrolling my slides. So at the first stage we calculated the short circuit currents, and further on we imply that during its operation these will be, there will be no problems. But this is our hypothesis, and this has to be checked. The main criteria for our retrofitting project, one reasons for retrofitting the installation were outdated the system of automatic control under the condition of digitalization into the energy installations, and in this one there is no remote monitoring. Besides, it is necessary to upgrade and partially to substitute the main units, the main blocks, and in general the component part has to be upgraded. During the retrofitting process, one of the main goals was using mainly domestic sensors and control systems to reduce our dependence from foreign-made technologies. It is our compliance with the policy of import substitution. And this topic is very important and topical today because the results, the findings, have a huge potential for scaling, for dissemination onto other similar situations with other types of wind generators. At the first stage, we made a scheme of the flow, and we analyzed the types of operations and processes. There are three possible types of wind under which the wind installation could be worked. From up to 20 meters per second is the latest wind regime. When implementing the project, we first of all analyzed the sensors used in wind generators in general. Mostly they were encoders, the centers who can help us evaluate the position of the rotating objects, the angle of turn, and also the measure the speed of rotation, the rotation speed. But we also considered other kinds of sensors. As a result, we selected some basic types of sensors for our retrofitting project. So at first glance, we selected these 6 types of sensors. In principle, the primary types of sensors would ensure import substitution 50% of that. So 50% could be domestic products. Speaking of the system of automatic control and remote monitoring, here the situation is much better. Domestic manufacturing industry makes it possible to produce the control system totally of domestic origin. And Oven Russia is our producer, our national producer. It produces controllers, and we are using this block. The result of our work with the automatic control system, the result is shown on the next slide. And this slide illustrates the connection between the primary sensors with other elements of the control system and their integration into the dispatching system and the remote monitoring system in Yantarenergo and in the regional dispatching center controlling electric grids of the region. After the retrofitting project, we would like our energy system, we are sure it will comply with the criteria required from such nets. The main conclusions are, at present in Russia there is a great number of wind installations of a similar type, and they could be retrofitted, and the operation life could be 10 to 20 years longer as a result. And replacement of the basic units and blocks onto the blocks produced in Russia will make it possible to reduce dependence on foreign producers. And the algorithm was developed for such a wind generation plant, and our conclusion is that the results which we will achieve at the end of the project could be disseminated onto other regions. And this project, the initiator of this project is Yantarenergo, our grid controlling organization, and the installation belongs to Yantarenergo. And we, as a research team, have been invited to their project as experts, scientific and engineering aspects. We are planning to continue implementing the findings of our research. Thank you. I would like to add, Valery Feodosevich Beley says, first of all, these wind installations on asynchronous generators, with asynchronous generators, their capacity is not more than 600 megawatt, and the starting figure is 100 megawatts. In the 90s, they were quite characteristic of wind parks. After 5 to 7 operational years, Instead of these wind installations, more powerful installations were assembled as a general rule up to 12 gigawatts, which make it possible to generate 5 to 10 times more electric energy, and the height is up to 155 meters. And these wind installations, according to different agreements, they were presented to us free of charge, and after 5 to 7 years of operations, Denmark presented us with quite a number of such installations, and they were working longer than 15 years on our territory. Now these 20 installations have been decommissioned, but after that different electrical companies were eager to buy them and bought them. And such installations could be found in Bashkiria, in the north of our country, so practical experience shows that they are capable of working 15 years more. So our task was to adapt, to upgrade and to retrofit such long-living installations to reduce our dependence on the spare parts and technologies produced in the West. That is why such a project was developed and implemented in Russia. And in mainland Russia there is also a similar project the team is working on that. And the Kaliningrad region, we have only one such installation, 600 megawatts. That is why our project is targeted at that. So if we did not, so it is the task which is inevitable for us. This is a good example which will make it possible after 2 to 3 years to create our own wind installations based on quite different principles and to become absolutely independent of Western technologies. It is a very topical kind of research. It enjoys support at the federal level. And the speaker, our today's speaker, is working at this topic in his master degree course and now in his PhD course. Now he is starting his research. So thank you, Gleb. You are the main executor of the project. Thank you very much for your presentation.
The next speaker is Yelena Berkova, who will speak about the analysis of options of using heat pumps for heat supply to independent or autonomous facilities. One of the priority measures to provide heat in the Russian Federation is the use of best practices and renewable energy sources, as well as the transfer to energy saving and environmental friendly energy sector. In the Kaliningrad region, there are facilities that are not joined to district heating networks, and these are rural clubs, holiday-making homes, schools and daycare centers, and they usually use coal-fired boilers. We have researched the possibility of using heat pumps as a replacement to the coal-fired boilers. purpose of the research was to analyze the options of the systems of independent heat supply using heat pumps. The facility, the subject of research was a daycare center in the village of Olehova in Ozorsk district of the Kaliningrad region. You can see on the map its location and an aerial image of the building and the area. Here there is also data about the main parameters taken into consideration when counting the capacity of the heat pumps. There was no data about power consumption. We have simulated that based on the standard methods presented in this slide, with the background data and the main formulas, which allowed us to identify the maximum amount of heat, as well as the monthly demand in heat. We have done the same for the hot water. Here you have the background data, the main calculation formulas, and the results we received with regard to the maximum heat production for hot water, the average annual amount, and that by months. As you can see in the graph, on the monthly basis, it's more or less the same value. The most probable heat loads were not possible to identify using the standard modeling. It only allowed us to calculate the maximum values for us to select the correct types of equipment. At the second stage, we did heating load simulation at the autonomous facility, taking into account the probabilistic nature of climatographical information in order to simulate a system where there is no need to choose equipment for the maximum load, where it's enough to have a facility providing 70% of the need, and in the peaks can be covered by additional heat generators. We developed an algorithm for the simulation, which is presented here, and we took into consideration the distribution of the ambient air temperatures during the heating season. We've done the selection and verification of the distribution law for temperatures corresponding to a given statistical temperature sample, direct modeling of a series of random temperatures according to the distribution law determined at the second stage, and calculation of probable loads from the simulated probable temperature distribution. This slide shows the results of the simulation. At the top, you can see the distribution of the outside temperatures of the ambient air Based on those forecasted temperatures, we modeled the heat load on the heating system, taking into consideration hot water supply. Here you can see the mean values for hot water and heating, and the maximum peaks, the maximum loads will be covered, as I have said, by heat generators that will work based on other type of energy, or those will be electric boilers. Then we discussed several options of the system using heat pumps. We considered 3 options. The first one, working in the monovalent mode with the heat pumps covering the whole amount of the demand for heating and hot water. And we have chosen 2 heat pumps, groundwater for heating with a capacity of 2 kilowatts, 2 heat pumps of geothermal type, soil water. We have calculated the number of circuits. 2 circuits will be needed, 100 meters deep. The depth of the wells is 100 meters. We have developed the principal heat distribution circuit, and the pumps, as you can see, are attached to every circuit. We have also considered 2 options with bivalent work, the alternative mode and the emergency mode. In the parallel mode, the heat pump can be the only heat generator up to a certain temperature of the ambient air. We have simulated, based on the statistical modeling, the temperature was defined as -8 degrees centigrade, and after the temperature goes down, the heat pump carries on working, but for covering the peaks, an electric boiler is added. The alternative mode was also simulated with the heating pump working, and after a certain temperature is reached, heat pumps are switched off and the heating is fully provided by the second heat generator, an electric boiler in our case. Here you can see the types of equipment. We have selected 3 heat pumps, 19 kilowatts, and in the parallel mode, an electric boiler of 18 kilowatts will be enough, and in the second option, an electric boiler with a capacity of 50 kilowatts will be needed. And for the probes, we proposed the depth of the wells of 85 meters. And you can see the scheme of the location, the layout of the equipment inside the premises. We have also developed the heat circuit of the subsystem of heat generation. And at the final stage of our research, we identified the electric power consumption by the heat pump, and you can see which share of power is generated by heat pumps for generating heat, and in red This is the power which is consumed by electric boilers and electric heaters. And from the table, you can see that the highest values in energy consumption accounts for the options with using bivalent alternative mode. And here you see the calculations of the costs of the monovalent mode, where the heat pump covers the total demand in heat and hot water. In parallel and in bivalent modes, the costs are nearly the same. In order to produce 1 joule of energy, then for monovalent mode it's the highest, and in the parallel and bivalent modes the cost for the generation of 1 unit of energy is more or less the same, meaning the bivalent and parallel mode of heat production is the most cost effective. And in one graph you can see the differences between the 3 different options that were studied in our research. Thanks for listening. Are there any questions? No questions.
The next speaker is Дарья Кугучева. The topic is simulation models of PV panels, photovoltaic panels, in the math lab environment, with the purpose of researching operational regimes. One of the most important tasks in designing energy generation systems based on renewables is achieving the balance between production and consumption of energy. Using PV panels, there is a problem of forecasting their generation amount because the weather conditions can change very much, and the temperature, outstate temperature, and insolation are variables. So in our work, we have implemented a model of a photovoltaic panel in the math lab environment, which made it possible to research the parameters of. We were taking into account analysis of insolation, so we developed the method of express calculation of insolation in the Kaliningrad region. And the outcome of our simulation modeling, we found the possibility of effective, efficient use of solar power plants, and we developed a device for continuous tracking of solar intensity. At the first stage, we calculated the values of insolation for every hour of the year for different types of panels, but we did not take into account the clouds, and we have also approximated these values to calculate the average monthly incoming insolation, and due to these calculations we see the influence of angles of inclination of panels onto their productivity. And we have studied a great number of different models of the cloudiness, extent of cloudiness, and we were trying to find the optimal model which was more adequate to the real situation. So we have chosen the Berlander model, which gives quite accurate data about the coming insolation compared to specialized sites. To simplify our further calculations, we developed a program for calculating insolation, which takes into account the previous data and those chosen within our research. And as a result, we are capable of predicting insolation on every day in every year on the basis of the knowledge about the weather. Using the developed program, we calculated insulation with different positions, different orientation of PV panels. And for Kaliningrad, we found that when we are carrying out a discrete and continuous tracking of the sunlight intensity, we could increase generation by 42%. That was our conclusion. The analysis of our system of tracking sunlight intensity, we found that our devices, due to their costliness, were not the optimal one to work with generation. That is why we developed our own helio tracker, which is simple in its design and quite economical. And we as mechanisms, we found step-by-step motors, and as microcontrollers we used an ampermeter of a certain type. Our work, the function is our work is for continuous tracking of the incoming sunlight, and the testing we carried out demonstrated the effectiveness of our system. Preliminary economic calculations demonstrated that the system of 2 PV panels for 250 watts, the costs will be $300. And because there are good prospects to assemble and to use these systems, we have received a certificate for this object. So when we calculated insulation, we made up a model in the math lab environment, which is needed to predict the amount of generated energy. The incoming data are the data about insulation. They are integrated from our previous programs, and the data for temperature of the air. And the outgoing data are the passport characteristics of this or that panel. So all the blocks presented made it possible to produce volt and watt characteristics of such a solar module, which will make it possible to determine quite accurately the influence of external environment, external conditions on the production, on the amount of produced energy. Applying our programs, we applied the software we developed at the academic and training farm, fish farm, belonging to the university, and the practical result of our experiment, of our testing, was the determination of the parameters for the operation range for such a panel under the conditions. And also we have proved the fact that our findings could be disseminated in any for any can be used in many similar cases for any project and design solutions. Thank you very much. I've got one question. It is a very interesting work. So, звезда научная. Кто? Новизна. The question was about the novelty of this research.
Научная новизна заключается в том, что именно для условий Калининградской области.
So, for the conditions of the Kaliningrad region, we developed the characteristics showing the influence of external conditions onto the efficiency for such panels, and we developed a new solution to maximize the generation of solar energy, electrical energy. It is a novelty research, but it should be formulated in a better way. She is giving some recommendations how to put it in better words. It is a novelty work. Are there any other questions? It is a highly scientific research work. Thank you. Success to you. And the next speaker is Andrei Nikishin. Юрьевич.
With Maxim Haritonov. The presentation is dedicated to the possibilities of regulating the schedule of electric loads using accumulators for realizing the concept of a green port. In the strategy of maritime sector development till 2021, the priority directions are related to sustainable development. At the same time, in Europe, since long ago, there is a trend of sustainable development. Also in relation to European seaports. Since 2006, priorities are formulated for every year, and the top 10 environmental priorities of European ports are listed on this slide. Russian port and European ports are linked by this topic. If we speak about reduction of emissions and replacement of traditional types of fuel by renewable sources and introduction of resource-saving and energy-efficient technologies, then these three tasks are similar for both European ports and Russian ports. Traditionally, ports receive energy from the regional grids which is generated by burning fossil fuel, and if these are replaced by renewable energy sources, then this will reduce the carbon footprint of ports and also reduce the greenhouse gas emissions. The implementation of all these tasks is impossible without using the concept of smart grids. This system is based on using renewable energy sources, power, solar and wind generation facilities. The reliability is ensured by a connection to the traditional grid. The consumers of the port economy, transportation and others, they at the same time are the participants of the program of regulating of demand for electric power. At the same time, there are certain barriers on the way of shifting to smart grid. And in our research, we have studied the need inside the port. Smart grid envisages that the object is maximum neutral. The port unites in itself energy consumers of various capacities, and if we include renewable energy sources in the system, then a problem will emerge about how the overall management of all those power flows will be organized to reduce shock moments for the internal grid. The link to the outside grid may be kept, and it will regulate the distribution of power. But for the owners of the port or of a port, it's not the best solution. Energy storage facilities are increasing in their importance. They are based on various techniques, batteries and other techniques. And at the first stage, the main way of using those energy storage may have an economic expedience if there is no national regulation. Then economy is the main driver. We can use storage facilities and save through paying less according to tariffs. In the future, storage facilities will be of a greater practical use. We have conducted a survey of the existing literature about using energy storage facilities for regulating the schedule of loads, and in the conditions of the Kaliningrad power grid, and our subject of studies was the Kaliningrad commercial port. And for companies of that capacity of consumption, the payments are made for actual consumption. At the same time, the company needs to declare its consumption 1 day in advance and pay for it, which causes certain problems because the loads fluctuate a lot. And this is how the cost of the power consumption 1 day ahead is done. And for our facility of interest, Kaliningrad Commercial Port, On the slide you can see how its internal power grid is organized. Using a mathematical model we managed to analyze the annual consumption, and this is the heat map, the heat consumption map from June 2020 and the annual average daily schedule. The analysis of the data showed, as we expected, here we can see the unevenness of the power load. If we introduce energy storage facilities in our model, then we can calculate different parameters. We can assess the volume of the power which it can store, the need for the capacity. We can assess the impact of the storage facility on various components. We can assess the mode of consuming power with and without the storage facility to know how much less a company may pay for consumed energy. And then if we specify the type of storage facility, then we can also calculate the payback period of the investment needed for buying it. It would be very interesting to know how the power supply is done involving renewable energy sources. The port doesn't have very good wind conditions, and yet we have done this assessment, and that's why we consider the possibility of using energy generated by the wind park in the village of Ushakova, which is in some 20 kilometers from the port. With the increase in the unevenness of energy supply, the losses on the way of transmitting energy from the windmill park to the port will also reduce. It is necessary to develop a full-fledged mathematical model of the port. For that, a certain amount of data is needed about the energy consumption of all the elements, of all the components that are part of the port, which so far was difficult. The preliminary conclusions are on the slide. And these are that a transfer to the concept of the green port is a conscious and inevitable process of the development of Russian maritime industry in the context of increasing technological and ecological requirements to ports. And so far, if we want to carry on this research, the problem is the difficulties in collecting the necessary data and the forecast of the loads in the port. But we will have to consider this need for the future, because this is what is happening in ports in Europe and worldwide. Are there any questions? What's the annual average wind velocity in the area of the port? It's low because the port is located within the overdeveloped area of the city.
Can I add something because related with the speed? If we are going if we are going for land wind turbine to the offshore wind turbine, the speed of the wind speed is higher and smoother that increase the lifetime of wind turbine. For this reason, a lot of ports that they don't have enough land, they are going to the offshore wind turbines in order to fit electricity.
Да, вы абсолютно правы, так и есть. Единственное, что вот на данном этапе мы рассматриваем максимально дешевые ресурсы.
The question was about the even. The question was. So more research is needed to take a closer look at whether offshore wind farms are often used because the winds are more even offshore than on land. That was the question by Professor Nikitakos. Discussion now.
Now the discussion is starting.
So two speakers have not presented, are not present. All the other presentations are of great interest, of significant interest. And the geography is very wide, from Greece to Germany. Petersburg participated. From St. Petersburg, there were two presentations. One of them was by this research team of Yelistratov, and Professor Yelistratov is the chief expert in renewable energy power plants. And the other speaker was Frolov, an outstanding scientist in his field, an expert. So these presentations were outstanding. My comment is that, and my comments are more addressed to the younger participants. When doing research, presenters usually went in great details, and I would not recommend young researchers to concentrate on the goals, on the tasks, and show the techniques used, and at the end it is necessary for younger presenters to formulate the novelty of their research. Do not neglect this part. It is more important than smaller details of your research. This is quite important because it is very pleasant for us. It is very pleasant that two of our graduation papers, bachelor degree and master degree, they became finalists of graduation papers in the all-Russian competition. 490 papers were presented. The leading universities of our country were participating. The Kazan University, the Moscow, the Ivanova. So I will wish the winners, our winners. Daria was one of the finalists, Daria Kugutcheva, the speaker, today's speaker. Yes. So I would like to wish her success in her research. I hope that we got acquainted with each other, and we will start preparing the third conference. We are all inviting. We are inviting you all to participate in the next such conference. Thank you for your participation. And if there are any more comments, you are welcome to say your opinion.
Are there any more comments and opinions? Professor Lee said that all the presentations were of considerable interest. He mentioned two of our he mentioned two of our leading experts from St. Petersburg who presented the forefront of science. And he has also mentioned that two graduation papers from our university became finalists of the all-Russian competition of university graduation papers. Daria is one of them, one of our speakers. And if there are any other opinions and comments, you are welcome.
Okay, can I make some comments?
Я хотел еще добавить, вот у нас конференция вначале нашу, да, внутреннюю, а потом еще внешнюю рецензию данного журнала. Сейчас требования к этим статьям очень высокие, поэтому там четко должна быть сформулирована цель, значит, проблема, цель, задачи и, значит, именно математическая составляющая и практическая и научная ценность работы.
Professor Believe has formulated some recommendations to the young presenters because the papers will be published in Scopus and the requirements are very strict, so everything should be very well formulated concerning the novelty, the objectives, the methodology. That was the additional information given by Professor Believe. Professor Nikitakis wanted to say something.
Let me add something in the last one. Comments for every paper, because I'm a reviewer in many journals, the main thing that we are looking is the added value. As the professor said, what is the innovation and the new item?
Профессор Никитакос соглашается, что, который сам по себе во многих советах и часто рецензирует скопусовские статьи, что обязательно должно быть подчеркнуто, что нового это исследование вносит в любой такой статье и выступлении.
Okay, let me do some comments there. Possibly I was a little misleading in this conference because I present something on digital business ecosystems.
Я немножко, может быть, не понял точно тематику конференции, потому что у меня цифровизация и вот электронные системы управления. Я думал, что это основная тема нынешней конференции, говорит. Он сейчас еще закончит?
I'm doing a lot of offshore wind turbines, and for me, among the most interesting paper was the paper that they are treating the wind turbines in Arctic area, because we are facing the same problems, new regulation and legal problems.
И корректируя вот свое понимание сейчас темы конференции, он высказывает мнение о том, какая наиболее актуальная, какое выступление было наиболее актуальным, то, которое касалось адаптационных вот механизмов для ветротурбин по отношению к арктическим условиям. Это, говорит, очень актуально и применимо и к другим ситуациям аналогичным.
Я хотел бы ответить, да, в каком плане, что у нас конференция – это экосистемы без границ.
So the topic of the conference was ecosystems without borders.
Да, и здесь три секции.
Three sections. Какие?
Цифровые.
Digital systems was one of the sections. Digital ecosystems. The second was society, ecology, economy. That was the first one, the first section. Green energy industry, the second one. Общим списком. So the publications will be published irrespective of which section they were listened to. There is a section in digitalization, so your topic was also important and suitable. They are all covered, different various topics are covered by the broad theme of our today's conference.
Okay, thank you for the invitation, and of course for me it was very useful to exchange ideas, because you can believe that you have to internationalize your papers and to write in English language, because if it is not in English language, you are losing your ideas to the wider audience.
Профессор подчеркивает, что очень благодарен за возможность услышать, что происходит в исследованиях в нашем вузе, что очень рад был обменяться опытом, и подчеркивает важность интернационализации вот этого обмена. Хорошо, что будет скопусовская публикация на английском языке. Это позволит профессиональной международной общественности быть с вами в контакте, знать, что происходит, и обмениваться с вами.
For me personally, I'm looking a lot of the polar climate change because the Greek maritime sector has a lot of ships that are crossing the polar areas, but I could not find. There are only in Russian language. So please publish some of your results in English.
Я, говорит, очень заинтересован, в частности, вот и в тех исследованиях, которые полярные регионы касаются, которые, потому что и моя область, судоходство, она тоже с этим связана. Греческие корабли подходят близко к полярной зоне. К сожалению, я только по-русски знаю, что есть информация, и буду рад, когда увижу это опубликованным на английском языке.
Otherwise, I should learn Russian, but it is too late for me.
Ну,
At the age of 60.
учить русский немножко мне поздновато, но в противном случае придется начать, говорит, иначе никак не добраться.
Еще, коллеги, есть вопросы или пожелания какие-то?
Any other questions, comments?
Вот очень четко сразу, так как он рецензент, и я рецензент этих журналов, да, вот эта научная составляющая, она должна быть в таких журналах, должна быть.
Just again, one small comments, because I have seen the heat pump and all the other. Possibly it was more appropriate for me to present another project that it is the zero energy building. I mean, try to reconstruct again a building to do it to have the zero emission. It's a big project, and we are working close to the Coast Guard station. And in this station, we are going to use a heat pump, we are going to use photovoltaic, and also we are going to produce electricity for electric car. Electric car is something else.
Профессор предлагает, в смысле не предлагает, а сообщает, что еще есть проекты у него, которые могли бы быть интересными, в частности, о энергонулевом по выбросам здании у него есть проект, и по электроавтомобилям в плане выбросов, то есть есть еще информация, которой можно было бы обсудить, поделиться. Лично он занимается. And Professor Billet said that he is very glad that you are of the same opinion concerning the information which should be stressed in younger presenters' articles concerning the novelty, concerning the objective, the goal. You are both of the same opinion in this recommendation to younger authors.
They are young, so they have time to be improved. Their scientific level.
Да, молодежь еще все исправит и все улучшит. У них жизнь впереди.
Они как раз как губки впитывают все.
Yes, they are acquiring all the useful information.
Ну что, если вопросов нет, мы конференцию закрываем.
So, if there are no other questions, we are closing the conference. And a special thanks to Dasha Kugucheva, who was helping very much and facilitating the discussions, and also Елена Дмитриевна Мороз. Елена Дмитриевna, also our organizer and supporter, and also to the specialists of English, our interpreters. And he is praising the interpreters, including me. I am very happy that she is teaching master degree students in our courses. Our master degree students should be absolutely fluent after the master degree course, and they will listen to lectures in English. лекции, что читают, да, наши доценты, and our associate professors are delivering lectures in English to them, so we are preparing. Закрыто официально, да? So the conference is officially closed. Thank you to everybody.